Save that. So let's just do another question here, okay? All right, so we could just so silly. Okay, and we will say we will have men, women. Okay, so we'll have sex or gender going down this way. And, you know, let me add another column here, sorry. We'll extend this. And then we'll ask, we ask them, do you identify yourself, your political ideology? Whoops. So, political, whatever. So, you know, do you consider yourself liberal, moderate, or conservative? Right? Politically, where do you stand? Okay, liberal, moderate, conservative. And we just ask. Pick one, okay? So, you know, people might have different definitions of what it means to be liberal and what it means to be conservative or moderate, but that doesn't matter. We're just asking, how do you see yourself? Okay, we're not going to give them a thing like, do you support this thing and not this thing and whatever to figure it out. We're just going to say, how do you see yourself? Are you liberal, moderate, or conservative? Okay. Okay, and so let's say the numbers here go like this: 30, 35, 35. We'll say, I'm just making up numbers here, okay? 42, 43, and 25. I don't know. Okay. All right. So this will be the table I'm providing you, and based on this, I'm going to ask you some questions. See if you can answer them. Okay. So this is a 25. Sorry, it's a funny looking 5. All right. We'll ask. What? That's not how you spell what. What percent of what percentage of the people surveyed are women? And what percentage of women are liberal? What percentage of liberals are, sorry, I don't know, are women? Okay, we'll just start you off with these 3 questions and take a few minutes and see if you can answer them, okay? I'm going to pause the video here as well. If you're watching online, you can pause it and work these questions out. Okay, let's go through and answer this. So let's add up. Let's create our total columns. Okay, how many men total are there? We add this up. 100. How many women total? 110. How many liberal people? 72. How many moderate? 78. 60, okay? Total of 210, okay? What percentage of the people surveyed are women? 110 over 210. And 110 divided by 210, 0.5238, okay? Any questions there? Okay. What percentage of women are liberal? So we do 42 divided by 110, and then, yeah, we'll get that in a moment. And what percentage of liberals are women? What do we do there? 42 over 72. Okay, can we see the distinction between these? Okay, so we're going to do 42 divided by 110, 38.18. And 42 divided by 72, 0.5833 or 58.
So it makes a difference if we put the 38.18 and the 33.33%. Do it make a difference if we just do 38?
Yeah, you know, I would say as long as you're rounding correctly, it should be okay. I would say keep at least a decimal. Probably good to keep at least one decimal point, okay? And especially if it's a tiny decimal, if it's a tiny number like, you know, 0.1 or 0.01% or something, then you want to keep more decimals there, especially, okay? But yeah, if you want to write 52.4% or whatever, that's fine. Okay? All right. Is this okay with everybody? Okay. Yeah. Or, you know, if you want to round off to one single, it would just be 52%. That's correct. Okay. So, here's a question. Is it more likely for a woman to be liberal than for a man to be liberal? That's a terrible color to use. I apologize. Okay, let me switch. Okay. Is it more likely, according to this table, okay, for a woman to be liberal than for a man to be liberal? Okay, and again, this is just made up data, so I'm not trying to make any kind of statements about the country or anything like that, genders or anything like that. This is just made up data. So, according to our table, we want to know, is it more likely for a woman to be liberal than for a man to be liberal? Okay, what numbers would I be using to compare, okay? Okay, so I shouldn't just look at the numbers here, okay? Because if I look at the number 42 versus 30, okay, it looks like, okay, but this is not what I want to use, okay? And I'll tell you why. Because there's more women than men, okay? So even if they were equally likely, we would expect this number to be bigger just for the sheer fact that there's more women than men, okay? So we want to know, how likely is it for a woman to be liberal? Okay? So which question answers that? What percentage of women are liberal, or what percentage of liberals are women? Okay? How likely is it for a woman to be liberal? Okay. So all right, so I'm going to label this one sentence A and this one sentence B, okay? Which one answers, okay, think to yourself, don't shut it out. How likely is it for a woman to be liberal? Question A, question B. How likely is it for a woman to be liberal? Okay, so what do we think? A or B?
B.
B? How likely is it for a woman? Okay, so basically what is the probability, or we can say what is the percentage of women that are liberal? How likely is it, if we pick a woman, the question is, how likely is it for a woman to be liberal? If I say, here's a woman, what's the probability that she is liberal? Okay, that is going to be answered by this question. What percentage of women are liberal? Okay, because it's not, is she a woman or not? We know she's a woman. We want to know, is she liberal or not? Okay, so to answer this question, is it more likely for a woman to be liberal than for a man to be liberal? We need two questions. We have to answer two questions. Okay, so actually, let me copy this over onto a new page so I have space to write all of this. Okay. Okay. Is it more likely for a woman to be liberal than for a man to be liberal? There's two questions we should answer. How likely is it for a woman to be liberal? Question mark. And how likely is it for a man to be liberal? Okay. So if we answer these two questions, then we can answer this question. And we just compare. Is how likely is it for a woman to be liberal? If this answer is bigger than this answer, how likely is it for a man to be liberal? Then we have the answer to the question, is it more likely for a woman to be liberal than for a man to be liberal? And the answer would be yes, if this number is bigger than this number. Okay, so how likely is it for a woman to be liberal? That is the same question. So I'm going to just write statement A here, okay, can be rewritten as what percentage of women are liberal? Okay, and then that means this one over here, B, becomes what percentage of men are liberal? Okay. Okay, and so to answer what percentage of women are liberal, we do 42 divided by 110, right? What percentage of men are liberal? We do what? 30 divided by 100, okay? What percentage of men are liberal? 30 over 100. What percentage of women are liberal? 42 over 110. I just want to make sure, before I go and punch these into the calculator, I want to make sure everyone is okay with going from this question into these two questions, and then from these two questions into basically these fractions here. Are there any questions? Okay. All right, so what percentage of women are liberal? we did 42 over 110, and I think we got 38.2%. And then what percentage of men are liberal? We get 30%. Is that okay? And so, if you are a woman, according to our data, you are more likely to be liberal than the man. Okay, 38% versus 30%. And so, the answer to our question, is it more likely for a woman to be liberal than for a man to be liberal? The answer is yes. It's 38.2% versus 30%. Is that okay? So far, so good? All right, let's try another problem like this, okay? I'm going to give you a table, and I'm not going to have all of these other questions in between. I'm going to just put this question, a question like this. Is it more likely for this than this? And then you have to come up with the right questions to ask and the fractions to be made, okay? All right, so I'm going to make up something. Okay. Owns a cat. Does not own a cat. And we will look at Los Angeles County versus Riverside County. I have no idea what percentage of people own cats, but I'm going to just make up numbers here, okay? All right, and I'm going to ask, is someone in LA County more likely to own a cat than someone from Riverside County? Okay. Is someone in LA County more likely to own a cat than someone from Riverside County? All right, so go ahead and take a moment to try to answer this question. Okay, well, I hope you guys took a moment to figure that out, and we'll go over the answer. So, what is the answer? Someone in LA County more likely to own a cat than someone from Riverside County? The answer is no. Okay, so let's break this down and figure it out. So you need to calculate two numbers here, okay? One is how likely is someone from LA County to own a cat, right? How likely is someone from, I'm going to just write LA to own a cat. Okay, and so that question is basically what percent of LA owns a cat? All right, and so to answer that, we would write what? 96 divided by 300, and we get 0.32 or 32%. Okay, so that is how likely is someone from LA to own a cat. Okay, and then we want to answer that, use that question, and then also answer how likely is someone from Riverside to own a cat. Okay, and so to answer that question, what fraction do we do? 32 over 100, and we also get 32%. Okay, so we see 32% of LA owns a cat, 32% of Riverside owns a cat. So is LA more likely to own a cat? No. No. Okay. All right, I'm going to trip you up. Well, not really, but I mean, I just want to show you the different questions that can be asked, and even if they sound similar and things like that, you have to pay attention to what the question is asking, okay? It's all of life, right? You have to pay attention to what someone is saying or asking or requesting, and you have to respond to that thing. Otherwise, you get it wrong. Okay. So what if I just asked this question, okay? Is a cat owner, okay, so cat owner from our data more likely to come from Los Angeles than Riverside? Okay, so let's just look at this. Is a cat owner from our data more likely to come from Los Angeles than Riverside? Okay, and so here we got to figure out the total number of cat owners we have, and we have 128. Okay, and then so we'll say, I'm going to just break it down into two fractions here. Yeah, percentage of cat owners from LA, and then percentage of cat owners from Riverside. Okay, and so here we have 96 over 128, and over here we have 32 over 128. And here we see the answer is 75% versus 25%. So is the cat owner more likely to come from LA than Riverside? Yes. The answer is yes. Okay. Okay, how are we feeling about all of this? It's feeling okay? Okay. All right, well, we'll keep working through questions like this for today. Next week, I'm going to just make it a little bit more complicated. And no more complicated than this? Well, not more complicated, but, because what if the number wasn't, okay, what if I had, instead of 96 people in LA own a cat, so this is next week. Don't worry about it today, okay? But just to pike your interest, okay? What if we had 90? Sorry, I keep using that color. I gotta say no on that color. What if this number was 98 rather than 96? Okay. So then it'll be so then my number changes ever so slightly, right? It's no longer 32%, but it's just a tiny bit bigger, okay? Does that suddenly mean LA County, it's more likely to own a cat from LA County than Riverside? So if we look at the numbers, what if, so here we got 32% and 32%, okay? But if I change that number ever so slightly, it might jump to 32.1% versus 32%. And so the question is now, does that mean you are more likely, is someone from LA County more likely to own a cat than someone from Riverside County? Well, that's the answer is not so, it's not so easy, right? Because um, this is not every single person in LA. This is I might say this comes from a random sample. Maybe I picked these people and I picked them at random, okay? I surveyed 300 randomly selected people from LA, okay? Now, if I went out and this time when I surveyed 300 random people, I got 32% owned a cat, okay? Now, if I took another survey of 300 people, what percentage of people own a cat? Will it be exactly 32%? It might be a little bit different, right? Because I'm just picking people at random. So the question that we're going to try to tackle next week, and you guys are going to hate it a tiny bit, okay? The question is, if we have something like 32.1% versus 32%, does that mean the group with 32.1% is more likely, or could it just be a result of the fact that I took a random sample that's not exactly the same? Okay, so he said, well, 32.1 versus 32, it seems like that could be a result of just the fact that we're picking people at random, and I happen to get maybe a few more cat people in this group than the other group, okay? But what if that difference was 35% versus 32? Now we don't know. Does that mean it's different, or is it still possible that it's just from randomness? Okay, so these are the types of questions. But we first have to be able to answer this question first in order for us to even begin to start doing that in the future. And this is a very, in my opinion, a useful skill, just because some people might make claims like, we took a survey, and here we got the, in 2013, there was a 45% success rate, okay? And then we implemented this program, and in 2015, the success rate is 47%. Therefore, we have improved, okay? Now, yes, there is a 2 percentage point increase, but could that just be a result of the fact that the people were different? And that's the types of questions, because sometimes people try to make these claims, and maybe it's not that big of a deal, okay? Maybe it's just from random chance. Okay, we'll get into this, okay? It's a little bit tough. But first, so this week we're just going to focus on these types of tables, and we're going to use that, okay? Next week we'll make it more complicated. Okay, so let me just do another one of these. I just want to make sure everybody is on the same page here. Okay. And I realize there are people who are ambidextrous, but we're just going to say, pick the hand that you write with the most. Left-handed or right-handed? Okay. Okay, and I'll ask, is a man more likely to be left-handed than a woman? So, we surveyed, we picked some people at random, and these were the results. Okay. So we're going to start off, we picked some people at random, these were the results. 15 men who are left-handed, 80 men who are right-handed, 14 women who are left-handed, 82 women who are right-handed. Does this mean, is a man more likely to be left-handed than a woman? That's our question. Okay, so go ahead and do the math. You should get two numbers to compare, and that should point at how we should answer a question. Okay, I'm going to go ahead and we're going to try to answer this. Okay, so we picked some people at random. These were the results. And we want to know, is a man more likely to be left-handed than a woman? Okay, so we want to know what is the likelihood for a man to be left-handed? Okay, I'm going to just abbreviate left-handed as LH. And so we do 50 and 80, and we get a total of 95 men. And so this question is answered with the fraction 15 over 95, okay, and we get 0.1579, so I'm just going to write 15.8%, okay? Is that good?
What if we forget the 8? It's a no, right?
Well, did you write 15 or did you write 16? 16%? 16%? 15 or 16?
15.
Yeah, 15 would be wrong. 16 is acceptable, okay? Now, I would say it's good to keep at least a decimal point, okay? So I would say 15.8 is probably, it's better to have a little more precision. But if you said 16%, 1/6, that's okay. 1/5 is wrong. Okay, 1/5 is rounding incorrectly. And then we want to ask the same question, what is the likelihood? Likelihood is spelled with an I, not a Y. Likelihood for a woman to be left-handed. Okay, and the answer there, we do, we add this up, we get 14 over 96. So I do 14 divided by 96, and I get 0.1458, or 14, I'm going to say 14.6%. Or 15 if you want to round up to 15, okay? But, I think, well, so the point here being, so this one is 15.8, this is 14.6. So according to our data, we have just an ever so slightly higher percentage of men who are left-handed than women who are left-handed, okay? But the other thing we want to keep in mind is that according to this, it says we picked people at random, right? So we picked people at random. So I could have picked another group of 96 women, and maybe I got a slightly different number of people who are left-handed, okay? And so the question is, so according to our data, yes, this percentage is higher than this percentage. Okay, we can see that in our data. But does that mean we can make a statement about all men and say all men have a higher chance of being left-handed than women? Okay, we're not ready to jump to that conclusion. Okay.
Is there any way that we can compare? What is the amount that we can say yes?
Yeah, so that's it's not like, oh, you get 3 percentage points, yes, or 7 percentage points, yes.
What is it?
We have to. It depends on how many people are represented in your data. So if you have lots of people, like if you surveyed thousands of people, then you only need a small percentage difference to say yes, this difference is big enough. But if you only surveyed a few people, like 30 people, then you need to have a huge difference to say yes. And so we're going to cover that next week. And there's I don't know, math involved there, and you might hate it a little bit. Well, so this week we're going to kind of lay some of the foundations of thinking about that, and then next week we'll get into the actual process of saying, is this difference big enough or is it not big enough? Okay. But, huh? Okay, so I'm going to write a few things on the next slide. Okay, so is a man more likely to be left-handed than a woman? So the answer here is going to be, in our data, yes. Okay? Does this mean, and then the next question, does this mean, however, men in general are more likely to be left-handed than women? Left-handed than women in general. Okay, and the answer here was probably not. Okay, I'm going to just say no. We'll have to gather more data. But does this line of reasoning make sense? I just want to make sure. Anybody who's struggling with this. Okay, so we use our tables to get at these questions. You know, is it more likely for this group to be categorized this way than another group, right? Is it more likely for someone with black hair to have brown eyes than someone with blonde hair to have brown eyes? Okay, we can look at the data and we can try to answer that question. Okay, but then we want to then say, okay, we took this data, can we then say something about men in general and women in general? Or can we then say something about people with black hair in general and people with blonde hair in general? Okay. I'm sorry? Yeah, according to this data, yes. Okay. But this difference, 15.8% versus 14.6%, that's like a 1 percentage point difference. Okay. And we want to know, is that a significant difference or not? That's what we're going after. Okay. Yes. Oops. It's from my other class. So I still have to write the homework assignment, but I'll have that posted, and it will kind of be working through two-way tables similar to this. Okay. and that will lay the foundation. And so this week so the stuff that I'm going to cover in our last 40 minutes of class will be just kind of the conceptual framework and ground, laying the foundation for the thought process that we'll go through next week. Okay, but as far as computations go with two-way tables, this week it's very simple. We're going to keep it like this. Next week, the calculations, computations will get a little bit messier. Okay, all right. It just I know.
Almost died in here.
Yeah. All right. Okay. So what we want to do, the idea is we're approaching this idea of statistical inference. And the idea is what we see in our data, okay, can that then be generalized to everybody, okay? So if we see something in our data, can that then be generalized to everybody? And everybody is, the technical term is called the population, okay? Can what we see in the data in our data then be generalized everyone, which is known as the population. Okay? So for example, okay, in the last slide, our data showed 15.8%, or what did I write? Was it 15.8% of men? Or 15.6? Okay, sorry. 15.6% of men were left-handed. And what percentage of women? 14 point... 4,
15.8 of men and 14.6.
okay, so 15.8% of men and 14.6, okay. And 14.6% of women were left-handed. Okay. So this is our data. Our data was collected randomly. Okay. So can we then say that for all men and all women, men have a higher chance of being left-handed? And the answer here is for all men, okay? So when we looked at our data in the last slide, what you just have written probably just on an earlier sheet, is that 15.8% of men were left-handed, 14.6% of women were left-handed, okay? So 15.8 is bigger than 14.6. There's no denying that. But does that then mean that when we're talking about all men and women in general, it means that men are more likely to be left-handed than women? And the answer is probably not, okay? We're gonna go through the nitty-gritty of the work, okay? But the answer is probably not, okay? Probably. Yeah, okay? So we'll We're gonna get through it, okay? But what if we might have another scenario, okay? And maybe we looked at let's say we go, to the last presidential election, okay? And we asked, are you registered as a Democrat or a Republican? Or I'll say Democrat, Republican, or independent, right? Or not with either of this party. And then we'll say, did you vote for Obama or not? Vote for Obama, did not vote for Obama. Okay? So I don't know what the numbers are here, okay? But we might ask a question. And this might be just we took a small survey, okay? Maybe we surveyed a total of 500 people, okay? So it's not anywhere close to being the United States. But we can ask, is a Democrat more likely to have voted for Obama than a non-Democrat? Okay? And then maybe it turns out, 75% of Democrats voted for Obama. And maybe 45% of non-Democrats voted Obama, okay? So we only surveyed 500 people, but can this then be generalized to the population and say, okay? And I would argue if the difference is this stark, 75 versus 45, I would say, yeah, probably this means that in the population, if we looked at all Democrats versus non-Democrats, we would see a difference as well, okay? Maybe not as pronounced as 30 percentage point difference, but we'll see a difference, okay? So the answer here is this probably, this is likely, this can be generalized to the population, most likely, okay? And we'll go through the nitty-gritty. So, yeah, here we're... I'm sorry? Yeah, we're just looking at, are they a Democrat or a non-Democrat, okay? And we want to know, does being registered as a Democrat, does that increase the probability that someone voted for Obama, okay? Versus the non-Democrats, okay? And we'll have to we'll look at this, okay? This does bring up a good exercise. So I just want to illustrate. Sometimes you might have more than two rows. Okay, so here I have Democrat, Republican, Independent. Okay, and for our analysis, you actually have to collapse things down into 2 rows. Okay, so let me demonstrate that on the next slide here. Okay, so the answer, we're going to answer that type of question next week. Okay, this week we're just looking at Okay, so we'll say voted for Obama, did not vote for Obama. Okay. I know they're already starting the campaigns for next year. Sometimes I, in California, we don't really see a whole lot of political ads for presidential candidates. But if you lived in Ohio, it's like crazy. It's just like commercial. It's because it's a swing state, right? In California, it almost always votes Democrat. So they both parties are like, we're not going to spend any money here. Exactly. Hmm? Right. But this, yeah, there's all sorts of things, but here, in our case, we're just want to know, so the question might be, is a Democrat more likely to vote for Obama than a Republican? Okay, and this is a silly question to pose because we know the answer is yes, right? Vote for Obama than a non-Democrat, okay? Okay, but here, you might have, the data might be split as Democrat, Republican, Independent, or, neither party, maybe not necessarily independent, maybe Green Party or something like that. And you have to ask, well, are you going to vote for your Green Party candidate, or are you going to vote for, one of the two primary, that's two-party system. That's just how it goes. So I don't know what, I'm just making up numbers here. Okay, so let's say 160 and 40, total of 200, maybe 40, 160, 200. So I'm just, here's 100, and here's 100, and 200. Okay, so we'll just.
400, 200, 400, 400.
Oh, okay. Yeah. So this is 300, 300. So this doesn't work out because Obama won. So this would have been a tie. But let me change one of these numbers up, just so we don't end up with a tie here. Okay, sorry. Okay, so let's do this. So this gives me 320 and 280. Okay, so let's do that. Well, okay, so in this case, we ask, how likely is a Democrat to vote for Obama? Okay. How likely is a Democrat to vote for Obama? And we would say 160 divided by 200, right? And we get 80% or something like that, right? And then the other part would be, how likely is a non-Democrat to vote for Obama? Okay? So here, for the non-Democrats, we have to combine these numbers and combine these numbers, okay? Because we don't just say the non-Democrats are Republicans only, or the non-Democrats are this independents only, okay? Even though that's what it looks like in Congress, in the population, it's not like that, right? And so here you have to add these two together, and you have 40 plus 120 equals 160 versus 200 over 200 plus 200 gives us 160 over 400, and we get 40%, okay? So even though there's 3 rows here, you just have to split it into, if it goes Democrat versus non-Democrat, okay? Or it could say, is a Democrat more likely to vote than a Republican? Then you can do 40 out of 200. But here it says Democrat versus non-Democrat, okay? We could ask another question, more likely to vote for Obama than a Republican, ... than a Republican. And then the question there would be, how likely is a Republican to vote for Obama? And the answer there would be 40 out of 200. Okay, 40 out of 200, 20%. Okay, so again, everything, you have to just pay attention to how the questions are written. Okay, non-Democrat doesn't mean Republican. Non-Democrat means not a Democrat. So you have multiple numbers to combine. Okay, so I just want to emphasize that. Is this okay? Okay, and so even if we only surveyed 600 people, if this is a random sample and this is what it looks like, I would say seeing this difference, 80% versus 40%, this is a stark enough difference for us then to say, for everyone in the population, we can say Democrats are more likely to vote for Obama than non-Democrats. Okay. Is that okay? All right. Let me pass out the sign out sheet. Sign these out. And we actually got through today's content a little bit faster than I had anticipated, so I think we'll just end a little bit early today. I think so. I hope I don't get in trouble for this. So.